Hey guys, welcome back to Algos Explained, and today we're going to go over one of the easy questions from LeetCode, and this is called non-decreasing array. And so I have the solution ready. What we're going to do is we're going to go over the problem, kind of think of a strategy for it, and then look at the solution, and then look at other solutions that may have been better. So let's go ahead. Non-decreasing array. Given an array with n integers, your task is to check if it could become non-decreasing by modifying at most one element. We define an array is non-decreasing if array of I, that's the current element, is less than or equal to array of I plus 1, which is the element right after, holds for every I, so holds for every single element in that array. And we're going to see some examples. 4 to 3, this is going to be true. You can modify the 4 to 1 to get a non-decreasing array. And example 2, 4 to 1, false. You can't get a non-decreasing array by modifying at most one element. And so if you look at the stats for this LeetCode question, it is an easy question, but it is the one with the least amount of acceptance percentage. And I think one of the big reasons for that is because the wording of this question is so awkward. Like non-decreasing. Who the heck says non-decreasing? That is such an ugly word. What does that mean? That means increasing. And so there is a caveat there, but let me go with increasing array. Let's look at it from that perspective. Instead of non-decreasing, let's think of it increasing array. So what are we trying to do? We're trying to see if this is an increasing array. Given an array of n integers, okay, we have a regular array of integers. Your task is to check if it can become an increasing array by modifying at most one element. So you gotta maybe a jumble of numbers, and what you want is, can this be an increasing array? Non-decreasing, that's such a weird word, and in interviews or whatnot, they're gonna throw stuff like this at you where the verbiage is just awkward. If you can pinpoint kind of where you see a word that you're not used to seeing and see if you can interpret it a different way, please do that, because non-decreasing array, that confuses the heck out of people. It drains your mental energy before you even get to the algorithm. We define an array, this next line here, we define an array is increasing if the current element is less than the next element. Of course, that's exactly what increasing means. And this holds true for every single element. And so with that said, okay, you can modify the first 4 to a 1. So you could change the number 4 to a 1 to get an increasing array. That makes a lot of sense. 1, 2, 3 instead of 4, 2, 3. Yes, that's increasing. Very simple to grasp once you start calling it an increasing array. This one, you can't get an increasing array by modifying at most one element, because what are you trying to do? You're straight up decreasing the whole thing, and so you cannot change. Well, first of all, you're triggered here. The 4, 2, that's not increasing, so you might change that to a 1 or a 2, but here you're decreasing again, so boom. And the only caveat, I said there was a caveat between non-decreasing and increasing, and the only thing is, if you have an array of all the same numbers, you can see here that I did test one of those. If you have an array of all the same numbers, is it non-decreasing? Yes. It's not decreasing, but is it increasing? No. And so the only thing you have to keep in mind when you change your own verbiage like that in order to kind of tackle the question would be, does it completely transfer over? And in this case, no, because of this one example of all the numbers being equal. But that kind of, hopefully that is a base case, or not a base case, sorry, an edge case that you do think of as you're writing the algorithm. And I don't think that should be a reason why you should try to tackle it with this non-decreasing array verbiage. Change that to increasing in your mind every time you're reading this. Think of it as, okay, I need to get an increasing array. That's all I'm trying to validate. And that'll make things a lot easier once you tackle it. And so let's go ahead and look at this from a perspective of what is it really we're trying to do. What we're doing is we're given an array of numbers, so that's an array, and we're just going to have to check, okay, are these numbers increasing or not? And it's not very difficult. Well, let me put it to you in this way. You say you're an assistant coach on a basketball team, and your coach says, okay, here's our team. Put everyone in height order from smallest to biggest. And so that's going to be increasing. And so what's going to happen is you do that. you try and you give him, okay, you give him the line of people. And so that's the nums. And so now the coach is going to come and the coach is going to, he's not going to look at it from one eye. Of course he can as a person, but what he's going to do is he's going to go to every single person and just compare him to the next one. And so he goes to the first guy. Is he smaller than the next guy or at least equal? And if he is, good, he moves on to the next person. Is this guy smaller or equal to the next guy? And if he's not, he's triggered. You can only make one mistake, and that's the one change that you get. And so this coach is furious at you. He hasn't fired you yet, but he is about to if you make one more mistake. And so pretty much what he's going to do is the coach is, okay, this guy, he made a mistake, let me move on. And by the time he gets to the whole line, if there was only one mistake you made, according to our algorithm, you pass. But if you made another mistake, if he goes down the line again, whether it be the next person that is out of order or somewhere down the line, someone's out of order, he has already been triggered, and so you are now fired. And so fired means the algorithm would return false, and if you make it through the array without having made any mistakes in terms of everything is increasing, then whether you made a mistake, one mistake, or no mistakes, you pass, and so that would be returning true. And so with that said, in the realm of algorithms, what we see ourselves doing is we have an array, right? We have an array, and what we're going to do is we're the coach. The algorithm is the coach, and we're going to move along the array, examine every single person in comparison to someone right next to him. And if that person is greater or equal, or is the person is greater, then you get triggered. If he was equal, that's fine. If he's greater, the coach is triggered, the algorithm is triggered, and you continue to go to the algorithm, and if you make another mistake, then boom, you're done. If you don't, good for you, you pass. And so let's go ahead and take a look at that. And so literally the variable that I made was trig, stands for trigger. And so right now, we're not triggered, or the coach is not triggered. He is fine, he gave you a task, and he just wants to verify what you did. And so what he's going to do is, through this for loop, he's going to look at every single person on that line, every single number in the array. It goes from 0 all the way to the end. We're going to increment it by 1. And so what we're doing here is, okay, the first check is, okay, we have the person we're looking at. This is the guy at the very front of the line. Is he greater than the one right next to him? And at this point, he's not triggered, of course, because this is the first person he's looking at. Is he taller than the one next to him? And if he is, then man, you made a mistake from the start. And so he will be triggered. But at the same time, he will be triggered. He will not fire you. He will not return false because he has not been triggered from the start. And so this case right here, this first if, is actually the end game kind of algorithm where he's already triggered, you already made a mistake once, and he sees that second mistake, okay, you're done, return false, you're out of there. And so the other portion, the real meaty part of the algorithm is in this next if statement where, okay, you check, and it is. So you are technically triggered here, which you see in this if statement, because you did make that mistake or that line, the person you're looking at was greater than the one next to it. And notice how I'm not doing greater than or equal to because it's a non-decreasing array. Remember, it's okay if all the numbers are the same. And so, yeah, the kid you're looking at is taller than the kid right after him. That's not how it's supposed to work. And so you're going to go into this statement. Before we look at this if, just know that, yes, he has been triggered now. And if you make a mistake in the future, or if there's a future mistake that's going to happen, you will return false at that point. And so, but there are some other cases that you do have to see, okay, are you able to, because you're able to modify the number, pretty much, are you able to change this guy's height to where he will not only fix your current problem, I mean, it doesn't really matter that you fix your current problem, but if leaving the guy as he is creates a future problem, then that's an issue. And so, can this guy be fixed to the point where he's not going to cause a false trigger? You don't want a false trigger. And so what we check here is, okay, is the guy before him greater than the guy after him? And if he is, then the guy after him is going to equal what you are right now. And I think, let's see, do I have an example of that? I think a great example would be just taking this out and letting this fail. And so let's let this fail. Okay, cool. So let's look at this. 3, 4, 2, 3, 3, 4, 2, 3. So obviously this is not increasing. It was increasing 3 to 4, and it's increasing 2 to 3, but it's not increasing entirely. And so what could have happened here? Actually, no, I don't think this is a good example because there's not one change that you can do, or this change wouldn't have helped it. But let's look at this example nonetheless. 3, 4, that's increasing, and so we're not triggered yet. But once you get to the 4, once your 4 is the I, you're seeing, okay, the 4 is now too tall in comparison to the guy after it. And so you would come here and check, okay, is the guy after or before the 3 greater than, or actually, well, because this case would have been false regardless. Maybe if I just return false here, we will get a better example. Okay, cool, yeah, let's look at this. And so we are here where, see, we modified the place where we would have replaced a number, and let's see, and we didn't. We just returned false instead. And so let's look at this. 2 and 3, that's fine. That's increasing. 3 and 3, that's fine too. 3 and 2, that's not fine. So while we're at this 3 here, the second 3, we're going to be within this else if statement, and we're going to come within here. And so instead of returning false at that point, if we had checked, okay, is this 3, the first 3, greater than this 2? And if it is, then we could have changed it to equal that 3. And in that case, it would have been 2, 3, 3, 3, 4, and that would have been fine. And so let's go ahead and take this example and run our code with the new algorithm or this old algorithm, and true, true. So we got that. And so I don't want to spend too much on this else if statement because I know that it's not the most optimal. And so we got the idea. I believe hopefully you have the idea of kind of the reasoning behind our algorithm now. And if you don't, rewatch it again. But moving on, at the end, if we had only been triggered once, we're fine. We could return true at the end. And of course, if there was no mistakes at all, if the whole array was increasing to begin with, you would never have been caught on this if, and you would have never been caught on this else if, and therefore you would have run through the whole array and we just return true, which is what we want. And so let's go ahead and take a look at the details. This is kind of where we see other solutions. And if you see a page like this is a good example of how the heck am I going to target something. Like, you can click on one of these guys to see the solution, but how am I going to look at number 1? It said that I was not the number 1. So go to this lower rectangle here, highlight an area, and boom, you'll zone into that. You see that I am not here. Most people are actually putting in this algorithm, but let's look at the best one. And I'll explain to you guys why this one was better than mine in terms of speed. And so he used a count instead of a trigger variable. That doesn't matter. What he's doing is he's incrementing the count, and his when the coach explodes is kind of when the count is greater than 1. He lets it, of course, increment by 1 from the start. But as you can see, if you scan through this, or actually, let's just go over it real quick. So yes, you have the number array, count is initialized to 0, and you are also going from the beginning to the end, incrementing by 1. And so this algorithm, the tactic, you're still scanning. You're still scanning from the beginning to the end, and you're going to make incremental comparisons. What this guy does, instead of comparing the current one to the next one, what he does instead is, he compares the current one to the one before it and checks, okay, was is this guy smaller? And so, I mean, that kind of goes more into the non-decreasing side if you're still thinking about that. But ultimately, he's just checking, okay, is my guy taller than the guy or not? And so we're checking, okay, is he smaller? And if he is, then the coach is triggered. And so once this is true, once this if true, he only has one if statement in here. He goes into here. Okay, was that the first mistake or the second mistake? If it was the second mistake, then count would have already been at 1, and so count incremented would have been 2. Therefore, you automatically return false. And then what he has is this next statement where, okay, if nums of I is less than or equal to nums of I minus 2, and so he compares a case where am I allowed to make more than one increment, or am I forced to ultimately make 2 increments in the future? And what I mean by that is he doesn't have any reassigning thing like I had. And what he does is nums of I, so he's looking at our current person. Is he smaller or equal to the 1, 2 before him? And is the guy after me smaller or equal to the guy 1 before us? And so if that is true, he returns false. And let's look at a case where that is going to be true. Let's try 5, 3, 6, 5. I'm just making this up. This might work, might not. Maybe if I add a 6 here. Okay, so I'm looking at the 3. Changing the 3 to a 5 will not help because I have a 5. Okay, so I'm going to ultimately make 2 mistakes at this point. We are decreasing and decreasing, and we want the whole thing increasing. So let's look at this algorithm, see if it will help us catch that before we even get to it. So our current number, let's see. He is triggered when I is less than the one before it, and so he would be triggered at the 3. And so while he's triggered at the 3, actually, let's change this to a 5 and a 3 here and a 4 here. Okay, so he would be triggered at this 3 now, and he would check, is our current number less than or equal to 2 before it? And so he's comparing it to that, and yes, it is. So, gosh, we would have to at least change it into a 5 to be true. And so that's totally fine, I guess, which is why there's an and, because in that case, one mistake, that's fine. That's the mistake that's not the mistake we were caught for, but it's not a killer mistake. But if that's in combination with the one after it, the number after it is less than the one before it. Okay, and so let's just do this. So now this is a case where this next algorithm is going to be better than ours. Okay, so again, 3, is that smaller than this 5? Yes. Is the 4 smaller than the 5? And so let's look at this again. Is our 3 less than our 5, and is our 4, which is the number right after it, is it less than the one before it, which was another 5? And in that case, we already made one mistake here. In order to remedy this 5 and 3, we would have to change that to a 5, but we already know that this is now still less than that guy, so ultimately we would have made 2 mistakes. And so in this optimal algorithm, you are not reassigning, but the bonus does not come from the fact that you're reassigning or not. It comes from the fact that you do like a less of a loop. You do one less loop. Because in my algorithm, you would have remedied this guy, but ultimately you would have been caught once you're here. And or in my algorithm, you get triggered by looking forward, so you would have been triggered here, remedied him, and then you would have been triggered at this remedied 5 to the 4 again. Whereas in this case, once you're triggered at the 3, you would at that position check for the 4 and the 5, and just return false without letting yourself go through another loop. And so that is this one here. I didn't want to look at this and just copy and paste it into ours because that's just not what I came up with. But going back, I mean that shows the beauty of this LeetCode website where you can see what kind of where you're at. And somebody did a very long one. Yeah, I don't even want to look at that. Feel free to look at that if you want to. But we ended up here. Optimal was here, and we discussed why that was better than ours. And so hopefully this helped you out. This is one of the least accepted ones, I guess, in terms of percentage. If you look at the problems, um, you'll see how there are acceptance rates. And so it was an easy one, but it's also a tricky one. Hopefully it helped you out. And if you liked the video, like, comment, and subscribe. And watch out for more videos. Thanks. Bye.